So we're going to be on example 7. I think you finished 6, correct? All right. So we're going to start out just looking at the series and determining whether it's convergent or divergent. So let's look at the first 5 terms. If you don't have a calculator, you're probably going to need to get it out. So let's just list. We're going to find the first 5 sums. All right, so the first sum of this series is what? 3 over 2 is just 1.5. The next one, after you add them together, you're going to get, anybody get the decimal for the next one? If you add the first 2 together, first 2 terms. First 2 terms. Yep, 3.75. Third term, you got to add the first 3. Good. 7.125. And the fifth one. I got 19.781 is what I got. All right. So if we look at these, just for the first 5 terms, what does it look like happening? Is it going towards a certain number? Okay.
It looks like it's just like exponential and it just keeps going up.
Yeah.
So it's like diverging.
We're just going to keep adding to it. It's going to keep on going and going, so it is diverging. So it diverges. So now those examples that you talked about yesterday and this one that we just did here, we're going to learn multiple tests over the next probably week and then probably even the week after Christmas break. So we're going to keep going over those tests. We're going to review them each day, and they're going to be able to tell you convergence or divergence. Some of them will only tell you convergence or only tell you divergence, and some will actually tell you what it converges to. So we're going to start that today. I think we're going to cover the first 2, maybe 3, but I think just the first 2 today. So the next page, let's see, geometric series. So that's what next in your notes? Okay. All right. So this box here, this is what you're going to have to memorize first, but we're going to look at several families of infinite series and several tests that will help you determine convergence or divergence. So we just talked about that. If we actually look at this, though, in the box, we're talking about sums, and it says the sum from 0 to infinity. We also have 1 to infinity. You could also have ones that say 2 to infinity. We're going to have an example like that later, but they sum to infinity. You're going to have a, so some constant, times r to a power. So the r in this case is actually referring to a ratio. So this r is going to be some kind of ratio here, and that ratio is raised to the power. So this is the form that we're going to look for. So you're going to have to be able to recognize a problem and say that it looks like this form and recognize that it's a geometric series test. So if you have this test and you have this ratio here, we're going to use this ratio with these 2 conditions. So the geometric series diverges if the absolute value of r, which is your ratio, is greater than or equal to 1. So that's the first condition. So we know if that ratio is greater than or equal to 1, the absolute value of that, the series diverges. If the absolute value of that ratio is less than 1, the series converges, and we actually know what the series will converge to. The series will converge to that right there, a1 over 1 minus r. So if it converges, we can find out what it converges to. Now this a1, that a1 just stands for the first term over 1 minus r. So a1's the first term. You'd have to actually plug into your series, find out what the first term is, and then put that over 1 minus r.
This is almost like P-series, but like the opposite It's like R is greater than 1 is diverges, but in P or whatever.
That's why we got to go slow through the section. There's going to be so much to memorize.
I'm gonna probably get that confused.
All right, so we know if it's greater than or equal to 1, diverges. If the absolute value is less than 1, it converges. And we know what it will converge to if it does converge. We can find that out. So let's take a look at the first example. If we look at the first example, is it of that form? No, not yet. Can we make it look like that form? Is there a way to make it look like that? All right. It's under this section, so there has to be a way to make it look like that. What do you think?
I'm going to say it's 3 times 2.
So we can pull the 3 out, and what did you say next?
Times 2 is a negative.
No. Yeah, you're going to keep the 1/2. But what do I do with the n now? Where does the n go? Does the n go with the 2, the 1, the 1/2? Where does the n go?
Can you just put another parenthesis and then put that in?
Exactly. So 1/2 to the n, well, 1 to the n is just going to be 1, or 2 to the n. So that keeps our 2 to the n there, and then we can multiply by 3. So that's exactly what we had just written now of the form of the geometric series. We have the constant out front. We have a ratio, and this ratio is raised to the nth power. So now we're of that form. So now we take the ratio, and we take the absolute value of it. So the ratio is 1/2. Absolute value of 1/2 is 1/2. So using that test, looking up at that information, since the absolute value is equal to 1/2, does it diverge or converge? Yeah, it converges. Since it converges, now we can determine what it actually converges to. So we need A1, so our first term. So what would be the first term of this series? What are we starting at? Where does n start? At 1. So we need to plug in 1 and figure out what is the first term. Yeah, 3/2. So 3/2 goes on top. And 1 minus r. What's r again? 1/2. So we get 3/2 over 1/2. And that simplifies to what? Simplifies to 3. So that converges to 3. Now, I don't have it completed from yesterday because this is the example she did, but if you look back in your notes at example 6, what did we find with example 6? It converged to 3. And did we have the same problem? Yeah, so we showed 2 different ways, but now we're actually using the test, so we don't have to list out all of the partial sums. If you have the test memorized, you're able to tell from the test what it is and quickly determine what it converges to. The first one is finished. All right, we need to look at the second one now. Any questions on the first one before we move on? Okay with it? All right, second one. Is it of the form of a geometric series? Yeah, the constant, well, there's nothing, just the 1 out in front. The ratio, so this whole ratio here is raised to the power, and it goes from 1 to infinity. So it's of the form of a geometric series. So now we need the ratio, which is equal to the square root of 3/2. So what does the ratio tell us? The absolute value of that ratio using the test. It diverges. Yes, it is greater than or equal to 1, so it diverges. So far, as long as you're going to be able to memorize it, is the test that hard to use? No. So once you get the memorization down, which we're going to go over each day, the test really is not too hard to use. So let's go on to C. I'm going to probably write down here where I have more room, but let's look at C. So we need to determine for C, is it of the form, do we recognize it as a geometric series? Is it of the same form? Do we have a constant out in front? Do we have a ratio raised to a power? Yeah, we do. All right, so what we're going to start with is determining whether that absolute value of that ratio, if it's greater than or equal to or less than. So ratio Now, before we move on too much further, so I know we already wrote down the ratio there and found out the absolute value, but if we're actually looking at this problem and we're plugging in values to n, what is this sum actually doing? Do you see a pattern that's actually happening? If we would plug in numbers, what's actually going to be happening here? Yeah, it's going to keep going from negative to positive, negative to positive. So a test that we're going to learn later on, if you want to label this, because we're going to learn about this, another way to find this one, it's going to be the alternating series. Alternating series. So we are going to learn a test about that later on, and it's just going to, they keep jumping back and forth. Positive to negative. All right, so now if we go back to this problem with the geometric series, though, we have 1/2. So which rule are we going to use from up here? Does it diverge or converge? It converges. Now we know it converges, but what does it converge to? Who can tell me what the setup is? Or tell me what the first term would be. 3/4. How'd you get that?
I put 2 into the equation.
Yeah, be careful. Make sure you look. It starts at 2, so you have to plug in 2 for the end. So the first term is 3/4 over 1 minus, and what is r? Yeah, make sure you're not using the absolute value here. It just says plug in r. Well, the ratio for this one is negative 1/2. So it's 1 minus negative 1/2. If it's off the screen, just yell at me. So we have 3/4 on the top, and then the bottom is 1 minus negative 1/2. So we have 3/4, 1 plus 1/2, so 3/2. What does it converge to? If you simplify that fraction.
1.
Yeah, the 3's will cancel. You have 2 over 4, which reduces to 1/2. So this one up here, it converged to 3. This one converged to 1/2, and the middle one diverged. Now, before we actually move on to the next test, what I want you can label it somewhere or make note of it. The geometric series test is what's known as a two-way test. It's a two-way test because it will tell you whether your sum is diverging or converging. We're going to have some test, the next one, that's only going to tell you one. It's not going to tell you both. So this one is a two-way test.
We want to go down a little bit.
Yep.
Like,
So geometric series is a two-way test. You can tell convergence and divergence. Yeah.
we were just, like, it says up top that, like, if the geometric series is in the form of, and then, like for the n equals 1, like, it says it's r to the n minus 1.
Mm-hmm.
Like, for b, it's not n minus 1.
So Mrs. Bauer and I talked about that a little bit yesterday before she left, and we determined really that the power and where it starts doesn't matter. As long as it's of that form and it's going to infinity, it's still of the geometric form.
Okay.
And after I actually watched a video on this again last night, and the guy also mentioned it could be n minus 1, this could be an n plus 1, as long as it's of this form.
Is the bound like n equals 2 or n equals like whatever, like as long as...
It's going to infinity.
Okay.
Now in this example here, so if you're looking at these two, so referring directly to this n minus 1, they're making these examples here look similar. So if you're starting at 0 and going to infinity, you're just going to have n. But if you're starting at 1 here, you have to have the n minus 1 for these to be the same. So they're just relating those two examples together. Okay? Any other questions? All right. Let's move on. All right, so the next test we're going to look at is the nth term test for divergence only. So this one is a one-way test. This will only tell you divergence. It tells you nothing about convergence. So if the test works, it will tell you it diverges, but if it doesn't work, that doesn't mean that it converges. It's a one-way test. So it even says that there. This does not say that if the limit as n approaches infinity of an equals 0, then the series does converge. This test can only be used to prove that the series diverges, hence the name. So if it fails, we must use another test, and always do this test first. So if you use it first and it diverges, you're done. But then if it fails, then you move on to another test. All right, so let's look at a few examples for these. So the first one, we need to look at the limit as n approaches infinity. So the limit of that one. We're going to use this test to see if it diverges. First one, so the limit as you approach infinity of this would be what? What is the limit of this? Good? Yeah. We're of the same power of n here, so we can take the coefficient. So the limit is equal to 2/3. So now go back up to that test, read it carefully. What does that tell us from our answer? Yeah, it's not equal to 0, so it diverges by the nth term test. Diverges by the nth term test. Let's follow the same process with the second one. The limit of this one as it approaches infinity. Kayla? Yeah. Again, the n's are being calculated the same way. So over here, they were to the same power. Over here, they're both factorials. So take the coefficients. It's equal to 1/2. Now again, using the test, it's equal to 1/2. So what do we know? Yep. Diverges by nth term test. Good so far? All right, let's look at the third one then. Again, we're going to do the limit as n approaches infinity. So if we actually look at this one, we take the limit. What do we get for the limit on this one?
1.
Yeah. Again, take the coefficient 3 over 3, which just reduces to 1. It's not equal to 0, so again it tells us what?
Divergent.
Exactly, diverges by nth term test. Diverges by nth term test. Good with that? All right, let's take a look at the next one. We have the limit as n approaches infinity again. And what is the limit of this one? As n gets bigger and bigger and bigger, what is going to happen? Yeah, the limit is going to approach 0. Now, by this test, since it's 0, what does this tell us?
Converges.
No, you can't tell.
Yeah, you can't tell. It's only a one-way test. We know these ones diverge, but just because this is equal to 0 does not mean it converges. So, the nth term test is inconclusive.
Didn't you do geometric series for this?
Exactly. So that's where we're headed next. If one fails, let's try to use another. Can we make this one look like the geometric series that we already know? It doesn't exactly look like it yet. What do we have to do?
We have to put out the one, so it's 1 over 1.1.
Yeah, we're going to pull out the 1. If we pull out the 1, I mean, we can write it there, so 1 out in front. That leaves us with 1 over 1.1. And what do we do with the n?
Put it outside of this.
Yep. So that is written the same way as this. It means the same thing. Now, by the geometric series test, what can we do? What do we have to do first?
Absolute value of the R ratio.
Yeah, absolute value of the ratio. Does anybody know what that is as a fraction? If you use your calculator.
11 times.
Less than 1 value, so 0.9.
10 11.
10 11s, yep. Yeah, I think you said 11 tenths the first time. So 10 11s. Now, that is the ratio, the absolute value of our ratio. So using the stipulations on the geometric series test, what can we conclude now? Because it is a two-way test, so now we can figure it out. What's the rule? Is this number greater than or equal to 1 or less than 1? This is less than 1, so we know it what? Okay, so it converges. And what does it converge to? What was that, sorry? I don't think. Let's look at it. Let's try. So we have to use a1 over 1 minus r. So the top term is the first term. So if we plug in 2, so let's do that first. What do you get for the term on the top? At least the way I did it, it looks a pretty big number. What did you get for the term on the top, or the first term?
1.26.
Okay, so if you leave it as the decimal, we could do that. 0.826. Then 1 minus r. What was our r value? We said 10 over 11 we could use. So I'm going to write this down this way a little bit. What did you get as your decimal on the bottom? Yeah. So the bottom is 0.0909. What'd you get? 9 what?
0.178.
I got 9.1 is what I, yeah. I got 9.090909. So it's either the 9.0909, if you want to write that as a fraction, I know I'm going way down the page now, but that is the same as 100 over 11. If you keep fractions throughout the problem, you would end up with 100 over 11. So 100 over 11 would be your fractional answer if you kept fractions and not decimals throughout. So we could not use the divergence test. It was inconclusive. So we recognized we could use the geometric series test. It did tell us that it converged. So now that we knew it converged, we could find what it converged to, and we found that that was 100 over 11. Okay? Any questions? All right, so that's where we're going to stop for today. I just want that kind of sink in. Maybe take a couple minutes since we have some time and maybe look over them again, try to do a little memorization, but that's it for today, all right?